Okay, so today we're going to be looking at the geometric sequences. So the geometric sequences to do with finance. So we're going to see the financial examples, and the first one we're going to do is a geometric growth example, which is compound interest. So as I said the other day, compound interest is when you calculate the amount of interest on the running total. So if, say for example, you're doing 20% of the total. So you start off with your first year and you'd have $100. Then you'd get 20%, I'm being generous, 20% interest on that first year. So the next year, when you go to calculate the interest, you've actually got 120, haven't you? So 20% of 120 ends up being, yes, that's right, $24. So can you see the amount that was added on has gotten bigger? Yeah, it was 20, 24, and so on. So what you'll see is a growth, and you'll see the graph. The graph is actually a curved graph, so it goes up like that. All right, so the amount that it is increasing by is actually increasing every time as well. All right, so we always, like always, we're going to have a recurrence relation model, so a basic formula that we're going to follow for that. So for compound interest, here, we're going to have this formula. So the way we have a VO, like always, which will be our principal. So what do I mean when I say principal? Initial value. Yeah, good, initial value, excellent. Then you'll have your VN plus 1 rule, which is always going to be equal. Now, we're going to see this big R value, and like we had before we had the D, we've got the R now. Now, you can see that the R is multiplying. So when you have geometric sequences, that means you're multiplying by something. You're either multiplying by a number greater than 1 or less than 1. So when you've got growth, you're multiplying by a number bigger than 1. Sorry, that was around the wrong way. Bigger than 1 if it's growth, and if it was decay, you're multiplying by less than 1. Okay, so because we're doing interest, it's growth, so our R value will be a value greater than 1. So how do I work out R? This is how we're going to work out R. So R will be 1 plus, now what we're going to do is we're going to use the little r, which is still that percentage per annum. Remember we were using R? And you still need to divide by PPY. What was PPY? Per year. Good, the amount of times per year. So you're going to work out that and add it to 1, and that will be this big R value there, okay? So this will be our recurrence formula that we're going to follow, and the way we calculate R, we'll use that. Okay, so there, and we also, because it has VN is always the value of the term at that time, or the value of the investment. So you might write that, value of investment, loan, after N periods. So remember, N periods could be monthly, it could be fortnightly. So if it's weekly, what would PPY be? 52, excellent. All right, so that's the recurrence relation or formula. So if we're asked to write it out in that format, you'll be told recurrence relation, and you've got to write that. Now, remember we had the nth term way as well. So if we want to find term 100, we don't want to be sitting on our computer pressing enter, enter, enter to get to the next term. So we use this nth rule or formula. So what that will be for the nth term formula will look like this. So we'll have Vn will equal, now you're going to have that R value, so whatever you've calculated that R value to be, and it will be to the power of N now. So if I said after 12 years, if this was a yearly formula, this would be to the power of 12. Do you understand? That's a power there. Okay, and then you will be times by VO. Okay, so if this is the formula here for the nth term, we could rewrite that, and instead of having R as R, we might actually put how we calculate R. So I'm going to put, that will be, we'll work out the R, so it'll be 1 plus R over PPY over 100. Okay, so that will be how you get, and then it will be to the power of that to the power of n times VO. So all I did is substitute what R is into that formula, so I could have a nice formula that I can use it for everything. Okay, so we might write down what those few things are. So VN is the value of the investment at the number of periods. After n periods. Okay, VO is your initial value. You know R, we've done R is like what you're multiplying by, yeah? Yeah, so it's not really the rate, it's the multiplying term. We might just write the formula there. That's what R is. And remember little r, so we've got little r up here. Little r is the percentage rate per annum. And n equals the number of periods. Okay, so you just notice that is a, when R is a number greater than 1, it is growth, yeah? It's this one, isn't it? Yeah? Okay, so if you have a look, as I said, compound interest, it'll have a curved line. So you might just write that there. It's a curved line. And if you look at the little bits that are going up, so the amount that it increases by is always getting bigger, isn't it? Is getting bigger each time. So not like flat rate. Remember it was the same amount. Remember we saw those arrows in the same chunk? Yeah, this one, they're bigger, aren't they? They keep getting bigger. So there's just a little bit of a summary. I've stolen that from something else, so but just to summarize. All right, so let's and do some examples. And have you got the answers there? Yeah, that's all right. So let's just go through it and just practice and see how we go. So an investment of $6,000, so there's VO, is earns compounding interest. So can you see there, that is telling you you're using compound interest. So when we have our summary sheet, we'll know to go to compound interest, yes? Okay, and at a rate of, can you see the 4.2 per annum? Did I tell you that, remember how I said your little r will be given in per annum? Okay, a recurrence relation that can be used to model this value of the investment after n years. So this is important too, this n years, because that's telling me that PPY is what? If it's yearly? 1. Good. So in the recurrence relation, the value of the investment after n years. So use this recurrence relation to find the value of the investment after 1, 2, and 3 years. So can you see, here's the formula. So can you see how in the calculator I popped in the 6,000 there? And then when I wrote, I want to times it by, because this is geometric. So when I did times, you would have seen answer there, wouldn't you? It would have been answer, and then you would have had times 1.042. Okay? So then you saw it, they wanted after 1, 2, 3 years. So then I just did that on the calculator. Yeah? Is that clear? Did you want me to show you on the calculator? No, you're good? All right. So determine how many years it will take to first exceed 8,000. So I was up to, this was 2, and I went 3, 4, 5, 6, 7. So I got to 7. So after 7 years, is when the investment will first exceed 8,000. Now it says write down a recurrence model for the value of an investment of $5,000. So here's a VO at a compounding interest rate. So that was very important that they've told me which one I've got to do, at a rate of 6.8% per annum. Okay, so we've got to do the whole process ourselves. So we would have gone to, we know it's compound interest, and we'll go to where our recurrence formula is, and we would have said we've got to write a VO. So what's my VO? 5,000. And then I have to write the VN plus 1, which is equal to VN, oh sorry, it's R, isn't it? Yeah? R times the VN. So that means I need to go work out R. So R in my case is going to be 1 plus, now it's going to be the rate, which is 6.8 over, now is it per annum? They want the yearly. So we'll just say over 1 over 100. And it is that's R, isn't it? So if I finally write out my recurrence relation, I'm going to get VO and then VM plus 1 actually equals, when you work this out, you'll get 1.068, yeah? So it'll be 1.068 times VN. So that is your recurrence relation for that. Everyone clear? If I go back. Alright, so let's do this next question. Write down the rule for the value of the nth term. So you know you're doing nth term here of the investment of $10,000, so that's VO. Okay, and the following, the investment on the account, and it has this recurrence relation. So you can see here, can you see that this part here, that's the R, isn't it? Yeah? So who can quickly look at that? What is the percentage increase that one is going? Because it's always 1 plus something. 9%. Can you see that? Because 9 divided by 100, yeah? So that's good. So use the rule to find the value of V4. So they want me to find the nth rule. So here they've given me the recurrence rule. So if I go to answer the nth rule, Vn equals, what was it? Go back, see? I'm too far now. Okay, so it's going to be, do you remember what it was? VO times R to the power of n, wasn't it?
Yeah.
I might have done that round the wrong way.
Yeah.
They had it like this, didn't they?
Yeah.
Yeah, okay. So let's do that. Let's write that in. So can you see our R is 1.09? So I'd say to the power of n. And what is VO in our case? 10,000. Good. So this is the answer for that part A. We've got the nth rule. And now they're asking in B, find the value of V4. So V4 would equal, 1.09 to the power of 4 times 10,000, which is going to equal 14115.82. Okay? Find the amount of interest earned in the fourth year, correct to the nearest cent. What you need to be careful with is this wording. Because it says in the fourth year, you're really only finding a year of interest, aren't you? Is that true? Because you only want that in the fourth year. So the way you find the in the fourth year, if I found the value of the investment after 4 years and then the value of the investment at 3 years and deducted found the difference, that would tell me how much it earned, didn't it? Yeah? So we'll write that down so that you're aware. So the amount of interest earned, is it earned or earned? Sorry if I spell things wrong. In the fourth year is equal to, so we're going to say V4 minus V3. Do you understand that? So in the fourth year, I got the value at the end of the fourth year, but I found out what it was to begin with, which would be the value at V3. So when we do V3, we can use our nth term formula. So it would have been V3, it would have been 1.09 to the power of 3 times 10,000, which equaled 12950.29. Then I found out, we already knew what V4 was, didn't we? We did it in the question before. So I've got that there. So we could say, therefore, 14115.82 minus 12950.29 equals 1165.53. So that was V4 minus V3. So the interest earned, here's the interest earned in the fourth year. So you need to be really careful. If they said how much interest has been earned by the 4 years, that means you would do V4 minus VO, wouldn't you? Because you want to know the whole 4 years. If you're only up to, if you only want to do in the fourth year, you would do like for there. All right, so if the interest compounds monthly instead of yearly, write down the rule for the value of this investment after n months. So what they want is the monthly formula. So we still want a Vn, so it'll be VO times R to the power of n. It's just that when we work out that R, so that's still 10,000. Now times, the rate per annum, it was 9, wasn't it? It was 9% per annum, but this time we're going to divide it by what? Because it's monthly. 12 over 100 to the power of, I'm missing the 1, sorry, 1 plus to the power of n. So if we tidy that up, Vn will equal the R, which is going to be, when you divide 9 by 12, you get 75 like that. So to the power of n times 10,000. Sorry, okay, so how did I know it was 9% to begin with? I'm looked up here and I can see that that's 9%, yeah? Because the R was found by going 1 plus something over 1 divided by 100, and it gave me 1.09. So you can work out that it's 9%. All right, let's keep going. Use the rule to find the value of the investment after 4 years. Now we've changed this to be monthly. So how many months is 4 years? 48. Yeah, 4 times 12 equals 48. So you're actually trying to find V48. So if I use my rule, V48 will be 1.0075 to the power of 48 times 10,000. And we end up with 14214.05. Okay, so V48. So I just want you to have a look at this. So this was after 4 years doing it monthly, and back up here was the value after 4 years going yearly. If this was an investment, a compound investment, so you're giving the bank money to hope that it grows, which one do you want the bank to do? Do you want them to compound it yearly, or do you want them to compound it monthly? Why? Why do we want to compound it monthly? Because we get more money. If it's a loan, and say this was a loan and I'm not making any payments, so just say for a moment we're just having this loan and they're just charging me for borrowing this amount of money, so the loan is getting bigger, which one do you think you want the bank to do? Yearly, because you don't want it to grow too much, do you? Because you've got to pay more back. Yeah. So that's what you sort of got to be aware of, the things of that. All right, let's look at the last one. How many years will it take the investment of 2,000, an investment of 2,000, paying compound interest? So we know here we've got investment, so you start writing VO at 6% per annum. So that's my little R, to grow to above 3,000. So what you're saying here is you want VN to equal 3,000. And they want how many years? So N is actually the question. Write your answer to the nearest year. So we're going to use, you could use your calculator, or you could use the VN formula. Let's use the VN formula. So we're going to say Vn equals R to the power of n times VO. Just over here, I'm going to work out what my R would be. And R will be 1 plus 6 over 1 over 100. Okay, so R ends up being 1.06. So back in here, I can write the formula 1.06 to the power of n times 2,000. And I want this value to be 3,000. Now, can you see the only little thing we don't know is n, and that's the question. So we'll pop in solve, comma n, and what do we end up getting? So n equals 6.9, so therefore after 7 years. It said the nearest year, after 7 years.